So, so this is our schedule, and we are at lesson 5 in the section 2, lesson for specific topic. Today, we are going to check how to access geometrical information through Symmetron API. The geometry we need it for calculation or some kind of automation. So, you must know how to access geometry and how you can use it. Okay, so this session is not may take 2 hours, even it complete in 1 hour. So after that, I have designed one assignment which include all our API lessons and the future lessons, the general introduction. Okay, so let me start with the geometrical information. So first, I am going to launch 25. Okay, and I'm creating Visual Studio C Sharp console based application. Today I'm using 22. You can use any version. So I'm not going to repeat these steps because we did it too many times. So I'm just selecting. Okay, so turn on. Okay. Let's take the same name. Okay, not specific. Okay. Okay, so let's create. Okay, so this is created as usual. I have to open Visual Studio in admin rights for compilation. So I'm going to open it in admin. Okay, so I have created a project and the console based project, and this is our then common implementation which is included in that template. Okay, so we have this symmetron. Let's create something. Maybe I can create slot or okay, then extrude. Okay, so we have this geometry and we have to access the geometrical data of this body, faces, edges, start point, end point, everything. Okay, so first thing is we have to get active document from Symmetron. So for that, this code is actually creating new document. I don't want it. I want to connect the active document. So I'm doing the changes. We already know in the application we have API get active doc. Okay, so this give me the active document. Okay, so let's open our document. So this is online help document. Okay, so in this API document, inside the Symmetron API, you can find many sections. Today we are going to check the geometrical information and topological objects. Okay, so let's talk about the topological object first. So we have this kind of class: body, face, loop, edge, vertex, point, wire, edges in 25. Okay. In broad level, I'm not going into the details. So you can see this solid, it is, and this is body. Okay. So if you select anything from the body, you can see like something is going to select. So this is body. If I select filter faces, we select faces. So these are faces, and obviously the edges. So these are the edges. So topologically, they have some kind of ownership, means body own faces, faces own edges, co-edges, vertices. So these kind of things. Okay. So Then second thing, the geometrical information. So each object must have some kind of geometry, just like a body have some kind of geometry, so that we can identify this is closed, this is wireframe. Then we can calculate the volume, surface area, and for faces we need like connected edges, then face surface area. Okay, like this kind of information. So let's start. So first thing is we have to um, get entity by type. Okay, so in this, I think in the lesson first or second, we already know how to get entity from Symmetron. We have to create a query first. Okay, then um, then using that query, we can fetch the entity by type. Okay, so let's take first. I have to. So I have to check the hierarchy as usual. I know that document is going to be converted model container, but I'm going to show you again. Where is the document? Part document.
Yeah.
Yes. So part document is has model container, and inside model container we can ask for model. Okay. So we are going to do the same. MDLR model, our model container, then cast document as model container. Okay. Then we can get the model. This is the active model. Okay, so let's check with the model. Okay, I need some kind of graph inside the model. This is MDLR model. Okay, so we have this MDLR model. We cast it as I model, and you can see here is return entity query. Means we can query some kind of entity through this model. So for that, we have to cast into the entity query, which is responsible to get some kind of entities with some type, some filters. Okay, I hope you remember we did this in, I think first or I think in both lesson, in the first lesson and the second lesson, which is actually the plugin. The first thing we have to do is we have to create filter. Okay, and which kind of filter? So I need entity by type. So here is the option entity type. Okay, and it gave me a filter entity filter. Okay, so based upon type, we have to cast it into the appropriate class. So let's check I filter. No, let's check in Symbase API. I filter entity. I filter type. We selected entity type, so we have to cast it into the filter type, I filter type, which is in base API. Okay, then we have to specify which kind of entity we are interested. So we can add like entity type. So interrupt. So let me get the body entity. And to get that, we have to add this filter into the query. I think set filter is function. Yes, set filter. We are going to set this filter to query, and we have to ask the query to select. Then using the select function, it give me the modeler API entity list. Modeler API I and same entity list objects. Okay. So using this code, what I did, I cast document to modeler container, get the model, then cast into the query, create a filter for entity type and add body as filter and set this filter to the query and ask to get the entity based upon my filter. Okay. So we need this code again and again. So I am going to add this in one function where I can get the entity list, get filtered, or get entity by type. Entity by type. And so let's copy this code from here to here. Okay, return as object. We need this model as input, so let's take it through argument. Okay, so our function is ready. Okay, so let's take entity by type, but we have to specify which type. So instead of using this hard-coded body, we can take it from argument. So yes, this. Then first argument is model. So model. Second one is the body entity type. So let me take body. Okay, so this return me the entity list. Mm, bodies. Okay. So in the symmetron, you can see only one body object. But behind that, actually body has two. One is wire body and one is solid or means the body which has face or something. But for wire body, there is no face. Okay. So behind the scene, symmetron has two body. One is the wire body, which is actually the sketch. Second one, this body, which we are going to select through this filter. Okay. So let's check how many bodies will symmetron give us. So for that, let's take for loop. I hope you remember we are not going to start loop from 0 for entities. We have to start from 1. So let's take each entity. I'm going to take each one. Okay, so I am adding comment like body here. Oh, okay. So we know we have created a filter for body and we get bodies, number of bodies. So this entity actually some kind of topology object, which is body. So if I check in the topology object, we have this kind of objects, topological object, and here is a body. So I can directly use or cast it as body. So let's like sim base API I body and I'm going to cast. Okay. So if I check inside the body, here is 2 3 function is wire, is close wire and formatter. Formatter is something which actually used for tessellation. We are not going to check it, but here is LM generator, which is responsible for the same tessellation. I think the link is wrong here. Okay, so even I think it is not documented yet. So, but we have API for tessellation. We can get tessellation of body, face. If I ask body, okay, so let's take back here, go to the geometry and go to the body geometry, inside body geometry. Okay, select the eye body. So if you select this kind of class in the topology and geometry, we have well documentation how to access the geometry and how to play around it. Okay. Uh, in from 20 in the new version, actually the Symmetron 2026, we improved our topological objects, which is much solid now. You can traverse from topology, from face to edge, from face to body, like this, forward and backward. Okay. Um, Today it is available, but it has some complicated structure. So for understanding the body geometry, I'm going to copy this code. So you can see here we actually reach at that point, we get the specific entity of body. I'm going to just copy this last two line. Okay, this one. So each entity has geometry. If I check inside the entity, there is a function geometry. If that entity has geometry like face or body vertices, then it is going to be cast in some appropriate object. In general, we have one geometry object, iGeom 3D. So you can cast it directly and take check like if it is body or not. So how to check that? So if I use the type, it give me some kind of enum. Let's check which enum it is. Geom type. Geom type. Geom type. So this enum can tell me like this entity is body or not. Okay, so I can simply check here. We can check like this must be a body. If I go inside the body, we have this point, curve, and surface. For body, we have surface. So let's check. Hmm. Okay, so we casted the body into the job body. So we have to check this program. So first thing we can do is we have to rebuild. Okay, it's built successful. Let's try to debug in normal mode. Here is the normal. Okay, I'm going to. Okay, so let's try to execute. In Symmetron, we have slot and extrude. Okay, so let's check. We got the active model. Our function is ready, which is responsible to get the number of bodies, number of entities of specific type. Currently, we are giving the body. So let's check. It must give the two. Yes, two bodies. One is the wire body, and second one is the solid body which has face. So we are going to traverse each body. So yes, it is entity, and you can see it is going to be cast in our body. That means it is basically a body. Okay, the body type is wrong here because this is body. So let's forget this. This is kind of some bug in API. But for checking the entity is body or not, you can simply cast it. This is the best way. Okay, then we got the geometry, and yes, we got the geometry pointer. So let's try to get some inside function of geometry. So if you check which are the function in the body, we have volume, we have center, box, projection area, and surface area. Okay, and also let's check in the okay, there is one more thing we have to check. Okay, is wire. We have to check like this is wire body or not. So how to check? So is wire. We have API in body is wire. If it is a wire body, it is simply give the return one value else zero. Okay, then we can take the value like volume, surface area. Okay, so our goal is to access the geometrical things of body like volume and surface area. So let's try to build. It's rebuilt successfully. So let's try to run here. So yes, we got the two bodies and let's check. The first one is wire body because first inside the symmetron, first we created a wire. So this is a wire body, sketcher body. Then if I take the volume because the wire has not a volume, so you can see the volume is NN.
Not a number.
Oh, yes. And the surface area is also not for wire, it is not mini. So let's take for the solid. So you can see the wire is zero. That means it's the real body, the body which has phase. Wire body is also real body. So if I ask the volume, it give me some number. Okay, and this is the surface area. So these are the things. The similar structure is also available for faces, for curves, and for points. Okay, so the concept wise to access geometry, it is same. You have to get the entity. You have to check which kind of entity it is. It may be a body, it may be a edge, it may be a face. Based on that, you have to cast its geometry into the object. For body, it is the 3D body, and for face, it is a it is surface. Body. Okay, for face. Okay, so in the documentation, here is a correction which I already raised. So here it must be iGeom 3D surface. So for faces, it must be a faces, and for curve, it is iGeom 3D curve. Okay. Then we can access the inside functions like volume, surface area in terms of faces, maybe get point on face, project point, something. Okay, so this is for body. So I'm going to paste this program in the chat. Okay. So let's take 3 minutes so that you can create some part inside Symmetron and try to get the geometry. Okay. If you have you like if you able to compile this and execute this program, and if you feel you still made, then you can try for faces the same thing. You have to just get entity for face, then cast into the face, and for face the iGeom 3D surface, and then call the function inside that object. Okay, so time's up. So let me give let me ask you, this program is okay for you? Are you able to get the area and volume? Anyone tried?
Yes.
And is anyone tried for a face?
Yep, this works.
Okay, so which kind of things you have called for face? Something
It's
okay, so let's take for face. We have to copy the most of things. As I said, the baseline, the structure is same. Only thing is like some kind of object getting changed. So instead of body, we are asking for faces. So this face. So let me change the variable name, the faces. Okay. So at the end, this is entity list. Even it is face, it is ISM entity, but it is not a body. So we can add face. I'm taking this as it is to show you. We can check the object type by just casting. Okay, and eyepiece is object, topological object, eyepiece. Okay, we have to take the geometry from entity. So this is geometry, and now we can't use the body function because this will come as null because this is a face. But for the sake of like checking, we just we don't remove this code. So okay, so let's take a reminder. Body must be null. Okay, geometry and also this should be a null because this represent a body geometry. Or maybe it is null. It's okay that we can use the only one thing, body. Okay, then we have to cast this into some object. So I geom 3D surface. I geom 3D surface. Now it is giving me some kind of values in the geom body. Okay, so we can see inside the 3D surface, we have some functions like normal at point, parameters at point, is planar, is parametric, u value, normal, many things. For surface, it is needed to know like which kind of face it is, which kind of geometry it is, and the parametric range and something. So let's call some functions. So let me take the parameters first. So I think range is function curvature elevate. Okay, so let me check planar parameter u discontinuity object curvature. Yes. Okay, so which thing we can call? We can call parametric, then curvature. For curvature, we need some kind of values. Okay, and inside geometry, do we have something for parameters? No. So let's call any function from surface. Let's take like area. We already know the area. Maybe yes, limit. Limit is a function which actually give the parametric limit of that face. So each face, actually the surface in the CAD, it is indefinite. To give some kind of boundary, we use limit. So for this surface, we can see this surface is not beyond the edges. So this actually represent some kind of parametric boundaries, and we represent it as limit. Okay, so if we check the limit functions in 3D surface, it give like some kind of min, max, u, and v. So here is the chrome. Um, okay. So inside this is a double array. You can see the double array, and the limit is the minimum v, maximum u, maximum v. So we can cast it to double array. Uh, limit. Okay. Then we can assign this value to some min u, which is limit first. Then wow, Visual Studio 22, I think intelligent. In the tab, it gave me the min, but I think the second argument is minimum v. The third one is maximum u, maximum v. So I want to confirm min u, min v, min v u, min v, max u, max v. So this is correct. Then we can calculate some mid parameters, right? So let's take like mid param. So for mid, we can use minimum u and maximum u divided by 2. Then for double mid v param, okay. Okay, so I just calculate the min of this u and v range. Okay, then I can maybe ask for 3D surface give me point of these coordinates. So let's take maybe we can calculate the curvature. For curvature we have to give I value, u value, v value, then it give me the curvature and directions. So I'm giving this mid u and maximum u. Okay, and let me take the all things as it is. So this is giving me the output C1 curvature value, then the curvature direction, then again C2 and direction. If you want to check the description of this function, I think it is added. So here is curvature. So you can see the curvature UV and this kind of output. Okay. So this give us the output. This is minimum curvature and maximum curvature. So that's why it is two mean value. Sorry, one is minimum and second one is maximum. So let's try to execute this program. So I'm adding breakpoint at 64 and trying to build in admin. Okay, so let's see. Okay, so let's check the body. Body is null. This is expected because this is a face. We took actually the faces inside the model. So this is a face. Then we cast it into geometry. Then surface geometry. Then we took limit, and it is a limit. This minus u minus this first one is minimum u, minimum v. Then uv the maximum. So we calculated the mean value and mid value of u and mid value of v. Mostly both are much near to the 0. This is 0 and this is near to the 0. If I ask the curvature, it gives me the minimum curvature 0 and maximum 0. and the direction may be the y-axis, x-axis. Okay, so if I check the entity ID, so let's check, this is 18. So let's try to check the 18 number ID in Symmetron. Okay, so this must be this face from that value. This is 18. Okay, so the curvature of this face is given through this API. There are many APIs inside the geometry surface. So if we check inside the geometry interface, we have this kind of APIs. You can calculate normal at point. You can test the point is present on the face or not. The discontinuity, close point, minimum and maximum radius, and area perimeter. Okay, so I'm going to stop and back to the document again, opening the geometrical information. If you check here, the all has actually this is the surface, iGeom 3D surface. So forget this. This is surface, but each face has some specific type also: geom, 3D plane, surface, cone, spline, torus. This is because for plane, there are some kind of geometrical information need to define that may be a minimum like point, normal, that's it, and that is plane. For sphere, it is only point and radius. So these kind of things, the specific things you can take by casting that geometry object into the appropriate object. Let's take example for plane. We have API to determine this is plane or not. So let's take. mm, So, so even we have API for surface type, which can give us the which surface it is. Okay, so return type is geom surface type. Okay, so I'm going to add this line just below the curvature. Okay, trying to use the one switch and giving this. Okay, so this give me the all possible options inside the surface object. The options are this: the surface plane, the sphere, cone, torus, spline. Okay, so in our geometry here in the symmetron, we have planar face. So let's cast. If the face is planar, then cast into the planar. Okay, so for planar, which object it is? iGeom 3D plane. iGeom 3D plane. 3D plane. Okay, if you check inside the 3D plane, let's take example in the document. Okay, okay. So it has three API. One is root point, one is normal of that face, and direction. So what
What is
will
direction?
be? Yes, I want to check that. What is direction? Because root point and normal is sufficient. To the plane which give the direction and scaling of u parameter line. Okay, where in that content? Okay, so are you familiar with u param line?
Pretty much, yes.
U direction of the surface.
I'm
So
familiar with that,
yes,
yes.
let me
Yes.
explain it in very short. Okay, so as we said, as I said, like each phase, like the geometry is infinite, but to limit that, we specified some kind of limits. Okay, in the code, we use that limit. This one, this is not actually the exact limit, but for planar, we can, for understanding, we can understand like this black spot is some kind of limit. Okay, and if I say like this is a u direction, u scale, and this is the v direction. Okay, that means this object I'm not able to draw, but this is the U min and this is the U max. So if I take any U and try to find a direction, then this is the U param direction. Okay, why it is needed? So basically it gives a information about that face shape. So imagine if you have wavy face, um, even this is round, but this parametric line may be much similar to this arc. For some kind of procedural phase, this line not following the exact the shape, it is some kind of other shape, and this is needed. Like where is the direction, and to understand that shape, and for some kind of geometrical operations.
You can see the
I
UV direction in Cimatron
how
under view.
view.
Yes.
The display curves.
Display curves.
Oh,
Yes, you pick the
Yes.
you pick one of the face. You set no. You need to set a value. For
okay,
example, 10.
sections.
Yes, like so,
Sections and cross sections.
and apply.
Apply.
Yes, perfect. Hmm. So this is directions. Okay.
Okay, so
So
here the U is like aligned to X, but not necessarily to the surface edge.
yes, it's not necessary to separate. Even for planar, it's not necessary.
Okay.
But for imagination, we can understood it is like that.
So
Just one question.
Yes.
Go on, say.
what kind of information you can get from the U and V?
Um. So like means inside the algorithm, we many time need the UV. So recently, I used somewhere. Let me check. Metro. I think so. Basically, some kind of algorithm. Like I recently use it in expand to chamfer. Here is maybe some option. This is expand to chopper. So I use this kind of information that the UV direction to expanding the chamfer because there are some procedural phase, and if that is come in between the chamfer, I have to use and treat as like chamfer. So for validation for some algorithm. Maybe I can give you some geometrical information like that where we can use this U and V. Is it okay?
Just
Yeah,
one question.
Yeah.
Sometimes you can hover, no, hover on a face, and you can see it's like a cylindrical face, and in parentheses there is an S, which is like simplified, like Cimatron simplified the surface to something simpler, you know. So if you select faces in the menu, yes, there is modify faces, if I'm right.
Modify
Modify faces,
faces.
yes. And there is fill or composite,
Okay, fair
which kind of
composite.
simplify the faces, but I'm not sure which one
Yeah.
will I get in the API
Uh, Everything
to
is
satisfy.
inside the API, I think, but it like it modify the geometry. Phase is something like we try to smooth the space if like some kind of waviness and something. So
No,
it
just
is
how to
modif.
treat it if it is simplified,
Okay,
or
so
how will
how
I know
to
if it
check?
is simplified? Yes.
Okay, so there are some kind of geometrical parameters like discontinuity. It also useful
Mhm.
to identify, and also the control UV net. So if we take like control parameters of this phase, I think it is also visible. So can anyone guide me how to display that control parameters?
I know you
Control
can
points.
modify it by sketcher. That's what I know.
Oh,
Modify by sketcher. Faces. And yes, here you can move literally every edge
no,
and
I
twist it and
think
like that.
no, this
You
is
can
not
drag it
control
for
point. Yes, this is like endpoints, but not control point. So I can
okay.
give you some code like discontinuity is also parameter, but this is mainly depend on the geometry and like things. You have to check many things if the surface is not smooth or smooth. And I think in recently in geometrical service, we have included one API which give you an information the surface is like smooth or not. Let me check. I don't know it is available here, but surely it is available in 26.
Okay.
Okay,
Body
so
center. Just another question. I've seen the API for body center. Click it,
hmm,
please. Get the center point of the given bodies. Is that center of gravity or center of geometry?
um, let's here is measurement tool.
A bit to the right?
No,
No, that's
right?
PMI.
Ah,
To the right?
yes.
Yes.
Hmm, let us. So I think here is center. Okay, this center, this one.
Okay. Okay, thank you.
Okay, so maybe in 26, I'm sure like the API, like you can check the given face is smooth or not is available in JOM service. JOM service, sorry, JOM service. So let's take inside of this, let's call maybe root point and normal. In the Symmetron API for procedural things like to execute any kind of procedure, we are trying to treat any point in the term of two things. First, like point can be defined through double array, and second thing like you can define point through like um, I point data. The difference is like if you give the point as this for any kind of procedure, like the procedure which need point like trim. So if you give the point data through the I point data, the existing interface, then it means like you are expecting the associativity maintained. If the point change, then your result automatically change. If you give the double value, then in that case the associativity not maintained. So these are the major addition in the Symmetron API we did. We tried to use the associated things. So right now in 25 there are many API which are not tightly associativity because in many where we are expecting the double value, not I point data. But for geometrical information or any operation other than that procedure, everywhere we can treat point as double if there is no meaning for the peak position, like where the point is peaked on the space, u value, v value, or something. Is it clear? So what I did, I asked the surface type. If it is planar one, then I cast into geom 3D plane and then take root point and normal. So let's check. We know the surface 18, 18 is planar, and we know the normal is 001 in the x direction. So let's compile this. If I check the ID is 18, it must be a planar face. So let's take, yes, this is surf plane, this is planar. So then cast into the plane, take the root point 26, 2300 and normal 001, 001. So you can face the individual geometry like cone, torus, line, surface.
Are those values from the active UCS or from the model UCS?
Model UCS,
Always.
always.
Okay, thanks.
Okay, so let's stop here. This is for loop. Okay, so I'm giving this code for face in the chat. So let's try. You can even check for other like face or cone or maybe procedural face which going to be cast into the spline. So let's take 3 minutes. Okay, so anyone tried?
I tried that before. Now I'm just looking at all the possibilities here.
Okay, so yes, this PI contour spline.
Basically, you can, the measuring pattern, you can implement all of it in the API, from what I see.
Yes. Okay, the thing which I have just described, the associativity, here is a one API interface MD point on curve. So if I use this using the symmetron point on curve, I have to select that some kind of entity. So let's maybe select this. Okay, the counter is 5, and then I have to select the start point where I have to start. So I have selected this. Okay, it should be there are some kind of reference point on curve. So let's take example because here it is much simple. Point on skin.
You had it before in the document.
Hmm?
If you go back in the document, okay, and one in the bottom, okay, point on curve. No,
Yes, yes.
you missed.
Actually, yes, yes. I take that, but it is like for point on curve, you gave the start point, right? Not actually the start point of that curve, not exactly the point. So like in the axis, we can define through the points. So like these axis. So let's take the axis, or maybe simply the line. Line is best. So here is a point, and if I use the point as this and this, okay, and create line. So line is created, and if I edit my sketch, um, so do we have another dimension?
Maybe try to take the diagonal, and then you can decrease the slot width. So you'll see the changes.
Okay, maybe we can, yes, we can use these dimensions, right? These maybe 200. Oh, okay, let's take bigger one, 500. Okay, and you can see the line is still created on that edge because while picking on the point, I pick the point on that edge. Okay, through API. If we check the line API, the line it is in edge, the advanced line. The document throw me somewhere else if I pick this. Okay. Okay, so let's take the point array. So I'm not able to show you, but we can check here. In many cases, in the point, it is asking like double value. So if you give the double value, that means that point start from that point. That case is something similar like um, take point using key in by using the int values. So that means you lose the associativity. Even that extrude is created or modified, we internally not going to associate that object with respect to that entity. Okay, so this means the associativity. So from this upcoming version 26, we are trying to maintain the associativity. And for that, we have one object, our point data. So whenever you see this object in the existing document as well, so you have to prefer to use this because this is something which maintain the associativity, the I point data. Okay, so is this clear? In the geometry, it is not needed, but for procedure, this is needed, like to know the I point data is available, and if it is, then try to use that instead of double values. Okay, so let's move to the next. The last section of this topic is actually the curves to access the curves. To do that, the curve, this main structure is similar. So I'm going to copy the above code and try to paste here. The first thing is I have to ask for the curves. So for curves, actually it is not enum like CM curves body face, but behind the scene, the topology and the curve is inside the edges. So seam edges, the edges. So this is ISIM body. So now face must be null as well as body. Okay, then this should be I edge. Okay. Then if I check inside the edge, there is no functions. Currently this is empty. So I took the geometry from the entity. Okay. And the surface going to be null. And we can take the iGeom 3D curve. So this is the common base class for the all curves. Curve also has type, like some curve is straight, some is spline like that. So if we take the curve type, it gave us an integer. Okay, curve type, geom curve type. Okay, then again try to switch. Okay, so inside state, we can check, like in our geometry there are many states, so we can take any. So if that geometry is state, we can cast it into the specific object. So for state, I so for state, let me show you that diagram again.
Geometry straight.
Oh, yes, I jumped. I jumped 3D state. So for the curves, we have these kind of types: the straights, ellipse, and INT curve. INT curve is spline. If you notice, in everywhere the iGeom is written before starting of the class. So we can write anything and try to use some keyword like straight is straight, straight. Okay, so inside straight, this is the root point and direction scale. this kind of thing. So let's take this value, the root point and direction. Let's start to compile in admin. So if you check, we got edges and it is 17. Okay. So if I go inside, it is going to be cast in edge and the geometry is cast. I'm asking the geometry type, so it is straight. So then going to cast in the straight object, so it is casted. Then I got the root point and direction. So direction is minus 7, sorry, plus 78 minus 0.6. Okay. And again it is straight. The direction is again the same. Root is different. Okay, so this is the way you can take the all geometry from the straight curve, the ellipse, anti-curve, and composite curve. So let's skip this composite curve. Focus on these three: ellipse, anti-curve, this is spline, and straight. So let me add here edges. I give this code in the chat and let's hold on for 2 minutes. The whole today's session is much like copy paste. So let's wait for 2 minutes. Then we are going to the next topic of this lesson, which is the assignment. And also we are trying to discuss the next lesson topic in very short.
Shai, are you going to show us how to create our own feature guide?
Yes.
Yes. Okay.
As in
Thank you.
today or another day?
Yes. Today I am giving you some
Okay.
kind of solutions, give you some broad idea, and I have prepared one solution which has two, three false. I can show you like where that two, three false. You have to repair it and understand the code. So just wait for 2 minutes. After finishing that, I can show you the everything. Okay, so 2 minutes over. Yeah, I hope you have compiled and used this code for accessing the geometry. Anyone has any doubt, questions?
No.
Okay, so perfect. So let's close this. and let's talk about the assignment and next session. So next session is actually oops, create a custom feature guide. Okay, it required 3 hours duration. So before that, what I have did, I made one assignment where I can give you some code which create a custom feature guide. You have to get familiar with that by by reading that code, debugging that code, and try to solve two problems which is existing in that code. Okay, so first let me show you the things. So this is a feature guide. When you register that tool, you can see a shapes is added in the object. It is rectangle, so forget about the name. You have to change this name rectangle to cube. Okay, so this is not big, but you have to change. Then change this tooltip, create rectangle to create cube. Okay, then you can see this is a custom feature guide. It is not in the semitone. This is created, and this nice image, one dot, and this is added in that feature guide. And on the left hand side bottom, you can see the guide message which we in the semitone usually prefer to show to guide user. So first is like select point. You have to select anywhere. So let's select. After selecting, I have asked some kind of values from user. The cube length, I have to create cube. Okay. Then I also ask like some kind of delta. The delta means, if let's suppose if I pick the point on the UCS origin, but still I want to translate somewhere else, then this facility, the delta, will translate that point and then create cube on that translated point. Okay. So these things, this is the only button. There is no need like translation value. Still, I have added to show you like you can add some kind of toggle button or push button inside the feature guides. And this is like double button or value button. Okay, so today if I press OK on this plugin, you can see a rectangle that is created, but it is hidden. So let me delete this. Okay, let me delete this as well. Oh,
Can you
oh,
use the
oh.
triad for the API for a feature
Uh,
guide?
which API?
Um, for instance,
Uh,
this Cube API, can you utilize the Symmetron triad?
no, no. I today I
No?
haven't used in the trial. I don't think it is an API. Okay,
Okay.
my Semitron is hanged, so let me
Just press
close
escape.
this.
It will be fine.
Escape. I tried to press 2 3 times.
It's escaping.
Last time in I think one session I tried to kill Semitron because of such issue, but then after it gave me some other problem. But let's take. Okay, so even task manager is crashed. Mm, okay. Okay, so let's start open new Semitron. So until now the assignment is clear. So first thing is you have to change the command name to cube. In the feature guide, you have to change that name from create rectangle to create cube. Okay. Then we can check the next details. Okay. So I press this button, cube, then take any and getting the cube length 50 and try to press OK. If I press OK, then it create a new feature in the feature guide. You can see here. OK, and a nice solid object is created inside Symmetron, but it is not cube. Okay, so your assignment is to like change this name, the feature guide inside name, this one. Then after pressing OK, you have to correct this math to make sure like this will create a cube. Okay.
Yeah.
Um, okay. Then let's talk about the feature guide, right? I am going to share that file, that code to you. Hmm, okay. Okay, then try to open it in Visual Studio.
Okay.
Hmm. So this is the com command. We familiar with the com command. We haven't like created any com command yet, but I gave you some details how to create. So let me explain it again. In the API template here in the C sharp we have com command. So I have exported this in Visual Studio and tried to create the com command. For the com command there is only one class, my com command, which is responsible to give the category name, command name, menu path, prompt, everything. Okay, so this class is responsible for command. So when user click on that button, so the call came to execute function. Okay, execute function here. And inside that function, I have created a feature guide. Create a feature guide. So the feature guide created. This is the class you can see here. This class is responsible to create a feature guide inside Symmetron. To do that, I made a connection with Symmetron. So we already familiar with the connection point. We I think checked. I not recall the exact session number, but we already discussed this. I made a connection with Symmetron with the Geo ID and advice. Then I said the tool feature guide titles, the bitmap, everything, and which kind of things I need, the apply button, cancel, preview, everything. Okay. Then create stages. So let's take example of any stage. So in stage, you can see the stage classes is having the many base classes. So this is because if I want to use the pick tool inside that stage, like in stage one, okay, you can see I am asking to pick somewhere in Symmetron. You can see if I press inside, going inside the view, you can see a nice icon for pressing collecting point from user. So this is responsible for pick tool event. So if I press anywhere, the tool event has called some function like on entity press, selection clear, everything, these kind of things. Okay. Also, there are some other classes also. The feature guide stage, tool event, um, tool stage events like this. So I'm not going into the detail today, but you have to study this. Okay, so best way to study like try to debug, try to add breakpoint everywhere and try to see what happened when you do some action in Symmetron. Okay, so is this clear?
Yeah.
Yes.
Okay, so in the stage 2 we added SP figures, right? So you can see here the SP manager. Okay, and you have to learn how I have added the SP figures inside that manager. Then one interesting thing which is not in the Symmetron API, the feature data. This class actually hold the feature data inside that cube, what is the data? The data is the peak point, double value, right? Today I have taken that point in the double value. It is not maintaining the associativity, but forget about that. This is the only assignment. So the first input is double value point x, y, z. The second is cube length, delta x, delta y, delta z. Okay, these all things are in um, double. So this kind of data I want to hold during the tool live. Okay, so I used this data structure, and this is I think generic in term of symmetron feature guide. You have to use the same even you have to create any other feature guide. Okay, so try to study that how this works. Okay, so that you can able to use for another feature guide. So this is
Feature guides
about
must be COM.
pardon.
Feature guides can be either plugin or COM applications.
Yes, either plugin or com, but com is
Okay.
preferable because I can explain this why we have to use the con. So let me first check what is the remaining things. The symutil, this class is responsible to get the general symmetron information, like model, entity, everything. Okay, math util is math util. Okay, so let's talk about that one. The callback and edit callback. Okay, so if you see today, if I press edit here, nothing is happening because for that I have to handle the edit callback, and this edit callback and callback available only when these classes is com classes. Okay, so that's mean it's best that if I want to create the feature guide, I am using the com plugin or com command. So I hope this is the answer for your question. So for feature
Okay,
guide,
thank you.
it is best to use the com. Okay, and whenever you use the com, make sure you have this value com visible true. Okay. The next important thing is to load this plugin, you have to compile this and open that register API exe. See program files 25. This exe in admin rights. Okay, not in normal rights. You have to use it in admin rights and then select the DLL. I hope I have that rectangle. Okay, and select the mycom command class. Give a nice icon. I think in that zip I have attached the icon. Select that icon and register. Then that command is registered and you can get callback for edit and callback. Today the edit is not supported in that, so maybe we can check if we have time. We can try to do coding for edit callback.
And the DLL
Okay.
must be in the Symmetron directory, right?
Yes, yes. For
Okay.
everything in the Symmetron API, even it is exe or DLL, it must be in Symmetron directory.
Okay, and the project that you sent simply compiles into that directory?
You need admin rights to compile, right?
Okay.
Okay. You don't have to change anything, I think. The setting is based upon um, that 24. It
When I
might be
opened
like,
it, it said that it's deployed in .NET 4.0, which I don't have.
can
So
you
to
share
update.
screen?
I already updated it. So now
Okay.
in the project, it's
Okay, okay. So
4.8.
usually the 4 point is required for this assignment. Uh, Even the Symmetron API is we use that framework for many operations. So you need to install 4.8 .NET framework. Okay, so I hope the assignment clear. You have to change the command name, the feature guide name. Then second thing, you have to do or correct the logic to create cube. And most important thing, you have to debug the code and digest the code. How the I have created SPs, how I can create the feature guide, and when the call came to create cube or something.
Okay. I'm
Mm.
sharing my screen. You can see that the references are broken in
Okay,
the file you
so
sent.
you just have to change the output path of that project. So just right click on the rectangle and
Properties.
don't change the project name right now. So just keep it as rectangle. So go to the build and instead of this output
Yes.
path, select your Symmetron output. Maybe for all,
Right.
you have to do these steps. I forget to do that.
Thank you. That's a good
So I hope
exercise.
yes. So I hope you can do that. And in between, if you have
Oh,
any kind of doubt, like why you write this in such way, or if you have any suggestion, just write mail to me, and then we can take quick call maybe, or maybe we can discuss it over mail. So yes, you already solved first issue. Okay. Okay. So perfect. So
okay.
thank you. Anyone has question, then please ask here.
No.
Okay, perfect. Then see you in our last lessons, and I hope you do this exercise and gain hands-on experience on creating the picture guide. Oh,
Akshay, if it's okay, can we have like a quick call after this?
yes, sure.
Yeah, yeah. Okay. Thank you.
Okay. Okay. Thank you, everyone. Thank you.
Thank you.
Thank you.
Thank you very
Thanks.
much. Bye.
Thanks. So,
Bye.
bye.
Bye bye.
Bye, thanks.